Okay, hello and welcome back, guys, into this new episode. Uh, last time I tried to show you how you can set up some mechanism in your framework so that you can exchange files with the HPC server. And I told you this is how you can also establish a real-time communication between the HPC server and your local machine, meaning imagine you have something that you're running there and you don't want to constantly go on the terminal window to type the command that is used to check if the job is done or if the execution is still going on. You don't want to go there and do it manually all the time. But for example, you want to have something like this where there is a command that the local machine is constantly sending to the HPC server to check if everything is done and if the data can be collected back to the local machine for further analysis. So, yeah, I'm not gonna show you like line by line how I do that because it takes a lot of time. If you saw the last video, you will see that it will take you so long to like to follow those different steps. What I can do here is in this episode I will just show you what I've done and explain, and in the next one I will go back and explain the code line by line so that it's easier for you to reproduce. So like you will not see me typing it, like it's not gonna be like live coding, but you will see the code and I'll probably also share it with you so that you can use it, customize it depending on what you are doing. We do anything. I want to go up here. Yes, I think I also have a text box here. So my HPC session is still alive. So if I hit this button, something will happen because these buttons are what I have these are those that I want to use to interact with the, well, not only these, but I use them to interact with the HPC server. So if I hit on this, I'm not logging in, right? But I think I'm checking everything that I have on my session. So if I hit, yeah, you can see here. So it's just basically going there and executing the ls command, like list everything, and everything that you see here is what I have on my HPC session right now. Basically, this button, I can use it to create a new folder on my HPC session. So if I want to, I will show you. I think I did it last time though, but I can do it again. Well, do we have to? Because I don't know. Anyway, let's make a new one. So let's call it new test folder. So this folder should be on my HPC session. Also, if I hit this again and I go, yeah, this is the folder. So it's there now. Something that I will do also now, and it's good, this maybe this is the only part where you will see live coding, but yeah, something that I will do now is I will explain what those are in a moment, but I have these hopefully it's yeah, I have these files that my actual commands are creating. Every time you're done creating them, I want to remove them in my HPC like in my HPC session. So what I will do now, and I will show you how I do it, is when we are done running and we know it's done, we can load, so we can collect all the information that we need because we know we are done, right? But because we know we're done, we can also remove them from the HPC session. So now you can do it. I think it's better if I do it here when I'm done collecting, because when I'm done collecting, I know that I'm done using them, because collecting here means I go and I would probably search into these different files and grab the information that I need to populate this table. Meaning when I'm done populating the table, I don't need them anymore. So I already have a command to remove them in my local machine when I'm done using them, but I can also use the same strategy to remove them from my HPC session when I'm done using them. So that's what we'll do here. Okay. Yeah, now let me explain what these are, because it's part of what we're doing today. So today, like I said, we want to use the idea of being able to exchange files between our local machine and the HPC server to create a real-time communication between them, so between my local machine and the HPC server. So the idea is very simple. Whenever I'm running something on the HPC server, there is a way to check if the execution is completed. One way is to use the SQ command to see if the job is still running. Another way is, in my specific program, I can create files that I would use to check the status of the execution. Another thing is, if there is a specific file that I make in my program in the end, like an output file, I can double check that output file and see if it's empty. If it's empty, then it means I'm not done yet. If there is enough data inside, then maybe I'm done, but I don't know. That's why having a text file with maybe a value like 0 somewhere is good to tell you that you're done. I use the text file, right? Because for the job that I'm doing now, well, I make binary files as well, but for the job that I'm doing now, it's easier for me to just open and see the running time instead of having the running time in the binary file and go read it. And it's also easy for me to work with someone else if I want to share. For example, I have like the result from my experiments and I want to share with someone else. It's easier for that person to open the text file and see running times instead of sending a binary file, because you're not sure the person you're working with is also a C++ programmer and will take those binary files to go read them in a script file. So I have those text files. What I do next is, whenever I start, okay, I need a Slurm script, which is this file, and that file has the configuration that I want to use on the HPC server. If I want to use, for example, 50 CPUs, and I want to set up the 50 CPUs as, 2 nodes of computations and 25 tasks per node. That gives me the 50 CPUs that I want to use. But yeah, anyway, so this Slurm script is where you set up those things, like the number of tasks per node, the number of nodes, the cluster that you want to use, the partition that you want to use. You can set up also the output file name, you can set up the log file name, you can set up the error file names. You can also, because it's a bash script, you can also add into it any bash instructions that you want to run while you're running the job on the HPC server. In this case, what I did was, because I run those several times, meaning the same MPI run or S run in this case, because I'm using a Slurm script, the same S run that I will run once to have an output, I am running it 30 times, or I think it's 30 times in this case. So let me show you what I mean. You see this command? If I run it once, I will have an output. I can run it several times to have a statistical population of the running time. This is really crazy. I'm so lazy today. I can run it several times to have a statistical distribution of the running time, and I need that to run my analysis. You want to run I'm doing maybe 100 times, right? So you can use you can do it, I want to say, in two different ways, but I don't know. I don't want to say two because someone can come up with a third option. So at least you can do it this way. You can create a loop in which you repeat this 100 times. And if this one is in your Slurm script, you can just load that Slurm script 100 times. But there is a problem with that. Whenever you load and you run a Slurm script, the system is going to look for the available resource to run the command, the job, right? So if you do that 100 times, I think it will allocate a resource for your job 100 times. But if you go inside a single Slurm script and you use bash instructions to run the MPI run 100 times, it will only use the resource allocation once. So you're only using one set of nodes and maybe no tasks per node. But for that specific set, you will run your command this many times, like maybe 30 times or 100 times. So that the letter is, for me, the one that is the most appropriate, because you don't want to penalize anyone else who is trying to do something on the HPC server just because you want to run your analysis. So be smart about it. So because we run it like 30 times, we will have these files, 30 of them. And so what we do is we ask our framework, when we start running the job, we ask our framework to check if we already have those 30 files. If we do we have the tag in the file that says this is the end, like this is where we stop? If we do, then we are done for all of them. If we do have that tag for all of them, we're done. And I think this is where I can go and show you what I mean by if we do have that tag, we're done. Let me go to the script here. Yeah, that's I have so many things that I've done here, and you can't even imagine. All this is we still have something in progress. When we have 30 files, meaning, oh, okay, we have all of them, all of the 30 files. Do we have the 30 files in such a way that they all have this tag in the end? Because this tag, like the end of script, is what I'm using to tell my machine that, okay, we're done. You can you know, if someone is trying to check this later, tell him that this is the end of the script. And so because I know I have someone else who is checking, that's why I used it. So this someone else is my framework. My framework is checking those files and see if we have these inside. If we don't, then the condition is false, which means over here this instruction is not going to be executed. And I just remember that I want to make sure if it's the case, we will continue adding up the value. So we will continue with this. Sorry, like I said, sometimes you think you're done, but you're not. All right, and that's for this. Okay, but if they all have this tag, it means it's done. So this is what it will show. It will pop, it will display a message saying, oh, the job has been completed, so you're done. You're free to move to the next task, next activity if you want, next whatever it is. I was just saying earlier that I want to be able to remove the files whenever I'm done. So I was thinking maybe if we're done, then it means I already have them downloaded in my machine. So maybe I can delete them here. So that's option one. But I don't think it's a good idea, because if we go back to the framework, when we're done, I normally collect those, informations. And I think this is where I want to do the go back and remove everything. So where do I have the script for that? Sorry, I think this is the script. Yes, I think so. And I think I only have, okay, oh my bad. That's crazy. Okay. It's okay. I think I can do it this way. Okay, because that one is, I use that one only when I want to actually, I don't need to create a new string. I can use the same and just change the command. Remove files now is you go in there and you say, okay, SSH. I will have to close this to do what I have to do, so because I need to run with the new instructions. So we will come back here and we will go into this backup. We will copy everything that is from the first iteration, because that's what we have right now that is working. And the main point of doing this is not to, it's just to show you how it works. Then later I can make sure everything is now functional for my research. So let me also close this. Now we'll run it. So it's gonna take into account the new things that I included. So just because I want to check, I don't want to do anything fancy here. Like, I don't want to go, I only want to work on these first 30 files, right? Oh, yes. If I click here, hopefully it will work, because I don't want to. If I click here, yes. So you see, oh no. So this first line is just what I want to have on the first line. Problem definition case. But now this is not what we want to check. If I click over here, I want to see if I still have those command. See, they are not there anymore. Perfect. This is amazing. This is amazing. Now I can show you the other comments that I have here, and I think that's gonna be, once I show you how it works, I think that's gonna be it. Like, I don't think you need to stay and see everything till the end, but the fact that you saw it when I started, it was 100 here, means that it was everything was working perfectly. So let me just go back